In the previous video, we have studied about limits, how to evaluate limits, and we have studied about the laws of limits. Based on laws of limits, we are going to solve some of the problems below. The first function is 10x plus 7, and we have to evaluate the limit for this function when x is approaching to 5. We know that this is in some form, so what we can do is we can simply take limit for each of the function. This is a function a, this is a function b. We can evaluate limit for function a, that is 10x. We can evaluate limit for function b, that is 7. We know that this is constant times some function. We can take constant outside. And we know that if you want to find limit for a linear function, that is equal to what it is approaching to. Here it is approaching to 5, that means the limit for this function will be 5. For a constant function, doesn't matter what it is approaching to, it will be always equal to that of a constant number. So limit for this function is 57. Okay, so even we can check it in graph. The red line denotes that of a function 10x plus 7. If we evaluate for 5, we're gonna end up here. That is when x is approaching to 5, the output that we are getting is 57. That's what we call limit. The second problem is we do have a function 3x minus 1 raised power 10, and we had to find the limit for this function. What we can do is we can take limit x approaching to 1, 3x minus 1 raised power 10. It is in the difference form, that is this function. What we can do is we can take limit x is approaching to 1, 3x, limit x is approaching to 1 for the function 1 raised power 10. We know this is constant times some linear function. We will take constant outside. For a linear function, the limit will be what it is approaching to. Here it is approaching to 1, so limit will be equal to 1. So for a constant function, limit is always equal to constant number raised power 10. That is 3 into 1 is 3, minus 1, that is 2, raised power 10. This is the limit for above function. We have a function that is in the form of fx divided by gx, that is in division. But if you want to use the limit law for this function, you must check if the denominator is not equal to 0. If denominator is equal to 0, then we cannot put it. That is 8x squared plus 2x minus 2. Since we had evaluate as negative 1, so we're gonna put negative 1, and this is 8 minus 2 minus 2, that is equal to 4. Since denominator is not equal to 0, so we can use the limit law for this function. What we can do is we can take limit for numerator and that of denominator. Limit as x is approaching to negative 1, 3x minus 4 divided by limit x approaching to negative 1, 8x squared plus 2x minus 2. We simply have used a division rule. What we can do is for this function, we can take limit individually. It is in the form of a minus b, that is in the difference form. Limit x approaching to -1, 3x, limit x approaching to -1, 4. Now limit we can take for 8x squared individually. Limit x is approaching to -1, 8x squared. Limit x is approaching to -1, 2x. Limit x is approaching to -1, a constant function. Now we know this is in the form of constant times some linear function. That is, we can take constant outside for a linear function. The limit is what it is approaching to. Here it is approaching to -1, so limit will be -1. We know for this constant function, doesn't matter where you are approaching, the limit will be always equal to constant number 4. Same is the case with this. That is, we will take outside, and it is x raised power 2. So simply, if it is in x raised power 2, x raised power 3, x raised power 4, doesn't matter what the power is. You simply have to put x as what it is approaching to. Here it is approaching to a -1, so we will put -1. In this, 2 is a constant function, 2 is a constant number, taking it outside, and x is a linear function, so it's approaching to -1, so limit will be -1. And the last one is, it's a constant function, so it will be equal to 2. If we solve it, it will be -3 minus 4 divided by 8 minus 2 minus 2. That is equal to -7 divided by 4. So the limit for this function is equal to -7 divided by 4. If we estimate it, it's around equal to -1.7, almost approx. We can see that this is a graph over here. If you want to evaluate limit for this function at -1 here, that is x is -1, the corresponding value is almost approx equal to -1.7. So for the input -1, the corresponding output is -1.7. This is what we call as limit. Let's move to the next problem. We do have function x divided by x minus 5. It's in the form of a divided by b, or f of x divided by g of x, that is in division. Let's check if denominator is equal to 0 or not. Denominator is equal to x minus 5. We had evaluate when x is approaching to 5, so we will put 5 in here. That is 5 minus 5 is equal to 0. So it's simply saying that we cannot use the limit loss for this function. So if I check the limit for top function, it will be equal to 5. And if I check limit for bottom function, it will be 5 minus 5, that is equal to 0. In this case, the limit will not exist. If you have a function and we can evaluate limit for numerator and that of denominator, we cannot evaluate. In that case, the limit will not exist. Simply limit does not exist. The reason is because it forms the asymptote. it will form the asymptote at x equal to 5. So this is the reason when you have asymptote, you get the infinity values. You are not getting any real number. So here too in the graph we can check that. If we approach x from negative side, the output that we are getting is negative infinity. If we approach it from right side, the output that we are getting is positive infinity. So limit for left hand side and right hand side are not equal. They are not approaching to a real number. So in that case, the limit will not exist, because this forms the asymptote x minus 5. If it was, let's suppose if it was limit x approaching to 3 instead of 5, then you can have evaluated the limit. You can have used the limit law. But since here denominator is equal to 0, so it forms the asymptote. In the asymptote, what you get is you are not getting a real number. It's getting positive infinity or negative infinity from left and right and left side. So limit does not exist for this function. Let's move to the next problem. This is also in the form of a divided by b. Let's check if denominator is equal to 0 or not. That is x squared minus 4x minus 5. We have to evaluate limit at 5. We're going to put 5 here. That is 25 minus 20 minus 5. That is equal to 0. So since denominator is equal to 0, we cannot. Even if we check at the top, let's see what the numerator is. 5 squared minus 5 squared minus 10 into 5 plus 25. That is 25 minus 10 into 5, 50 plus 25. So 25 plus 25, that is 50 minus 50. That is equal to 0. That means the top and bottom both are 0. In that case, when the top and bottom is 0, it is undefined. It never means that limit does not exist. It simply means that we cannot evaluate by this form using this law. What we can do is we can factor the numerator and denominator and see if we can cancel any term. 0 by 0 form never means that we cannot evaluate limit. You have to take other way, then only you can find the limit for this function. If I find the factors for this, it will be x squared minus 5x minus 5x plus 25. That is taking x minus 5, x minus 5. So the factors for this is x minus 5 into x minus 5. We can take for this too. That is x squared minus 5x plus 1x minus 5, x minus 5, x minus 5 plus 1. The factors are x plus 1, x minus 5. So if we see for the top part, limit x approaching to 5. For numerator, factors are x minus 5, x minus 5. Bottom has x plus 1, x divided by 5, x minus 5. So what you can do is you can simply cancel x minus 5 and x minus 5. You are left with limit x is approaching to 5, x minus 5, divided by x plus 1. Now if you put 5 in the denominator, it will not be equal to 0. So what you can do is you can simply put the value of 5 in the function. What you can do is, this is in the form of a divided by b. What you can do is you can take limit separately for in case of division. Now we can use the limit law. We can use the limit law. Because in the first case we couldn't use the limit law. The reason was it was in the form of 0 by 0. That means we cannot use the limit law. But here, since the limit for function a and b both exist, so we can evaluate. Limit x minus 5, limit x plus 1, you can simply put separately, or you can directly, if you want, you can directly put 5 over here. That will be equal to, the top part will be equal to 0 and the bottom part will be equal to 6. That is 0 divided by 6, we know it is equal to 0. So for this function, the limit is equal to 0. Limit is equal to 0. Even the graph we can see, this is a function, the two red curves. If you are approaching x equal to 5, here we can see the corresponding y value is equal to 0. So for input x equal to 5, the output is equal to 0. So the limit for this function is equal to 0. I will show you, this is an example, you can see it yourself, or I will do it a similar case with like this. We do a function. We cannot evaluate limit law for this because the denominator is equal to 0. The limit for denominator is equal to 0. So in that case, we cannot evaluate the limit. We cannot evaluate the limit using the limit laws. So what we can do is we cannot simplify this expression like in the above, how we could find the factors and then simplify. We cannot do this for this. So what we can do is we can factorize this. Limit x is approaching to 0, x squared plus 4 minus 2 divided by x squared. That's, we can multiply both of the terms with this x squared plus 4. Instead of negative, we will use positive 2. The reason is because it will be in the form of, I will show it to you. We have to divide by x squared plus 4 plus 2. So we are multiplying this with same term above and below. So there will be no problem with the equation. There will be no change in the equation. The reason, we know that from formula we have a minus b, a plus b, that is equal to a squared minus b squared. This is the reason we have taken it in the form like, here it was negative, we have taken the positives to make it like a minus b, a plus b. So this is a, this is b, this is a, this is b. So it is in the form of a squared a minus b, a plus b. That is, the result will be a squared minus b squared. So a is root x squared plus 4 we have to take square for this, and then b is 2 square for this. The below term is x square plus 4 plus 2. What do you know that this square and this will cancel. That will be equal to x square plus 4 minus x square, 2 square is 4, and we have x square plus 4 plus 2. So we will cancel this. Okay, the top will be x square, in the bottom 2 we have x square, we will cancel this too. So if I simplify it, limit x is approaching to 0, the top part is 1 divided by x square plus 4 plus 2. We know this is in the form of a divided by b. What we can do is we can simply evaluate the limit for numerator, that is 1, and limit for denominator, that is root x square plus 4 plus 2. We know for a constant function the limit will be equal to constant number, and if we put it 0 over here, it will be 0 square plus 4 root 4 plus 2, and on simplifying it, it will be root 4 means 2 plus 2, that is 1 divided by 4. This is the limit of this function. Or if you want to simplify it more, it will be 0.525. So limit for the above function is 0.25. Even in the graph you can see this blue line is the curve of this function, and we do have to evaluate limit at 0. We know the corresponding value when x is 0, the corresponding value y is equal to 0.25. This corresponding y value, this is what we called as limit. Now this is same x square minus 1 divided by x minus 1. X is approaching to 1. So we know that we cannot evaluate the limit laws a divided by b, because denominator and numerator forms. In general case, when the numerator and denominator are equal to 0, then you should try to use algebra and simplify the expression. Likewise, how you use in the above questions. Okay, here what we can do is, if we take see the factors of x square minus 1, it will be x minus 1 and x plus 1. And for the bottom, you can simplify it as negative bracket x minus 1. Then you can cancel the terms, and now you can use the limit law, or you can simply put x as 1 and you will get negative 2 as limit. Now coming to the last question. Evaluate limit for x approaching to 0, x cot x. Now your first reaction would be, what you want to do is that you will use a product rule, and it will be you'll say it is in the form of a into b. This is a, this is b, and you will try to evaluate limits. But this is not the case, because I told you you can only use the limit laws when limit for both of the function exists. If it does not exist, then you cannot use the limit law. Instead of this, we do have few methods. For example, we know if you want to find the graph for x cot x, it is like this, and you had evaluate limit at over here. The limit is almost and x is approaching to 0, either from right side or left side. The output that we are getting is that is approaching to 1. So this is limit for this function. Even you can use a table. First you will take from, if you want to take from positive side, then you will take 0.1, then you're coming more closer, 0.01, more closer, 0.001, more closer, 0.001, and you will find what the function is approaching to. You'll find that function is approaching to 0.9999, so on. That is almost approx equal to 1. And even from the negative side, 0.1, 0.01, negative 0.001, negative 0.001. So when you are coming more closer and closer, you will see that the value is getting closer to that of 0.9999, so on, and that is almost approx equal to 1. So with the help of table or graph, you can evaluate the limit, but we can do it by some other way too. Let me show you how. Let's suppose you want to find limit for this function. Limit x approach to 0, x cot x. What you can do is limit x approach to 0, x into cot x can be written as cos x divided by sin x. Now we must observe that if the terms x, cos x and sin x have any kind of relation, there is any kind of relation between two. Yes, I can see that there is a relation between x and sin x. Okay, there is a relation. So we will take them aside. Limit x is approaching to 0, x sin x into cos x. Okay, we know, for example, you have a term 3 divided by 7 into 5. If you want this to get inverse, okay, you want this to be like 7 divided by 3, what you can do is you can take it in the division and then it gets reversed. This is what you can do. This is what we want to do with this x divided by sin x, because we know we can find the limit x approaching to 0 for sin x divided by x. We have solved it in the previous video that the limit for this function is equal to 1. So this is the reason we want to get in the form of sin x divided by x. So for this, what we should do is we should take it into the denominator. When you're taking the denominator, it gets reversed. For example, if it is a by b, it will be b by a. So this will be sin x divided by x. Now you can use the limit law for the top function, and for this is numerator, this is denominator. You can use the limit law. That is limit x approaching to 0, find the limit for numerator, limit x approaching to 0, find the limit for denominator. We know that when cos x, if we put x as 0, when you are putting x as 0, right closer to it, the output that we get is 1. We simply know that cos 0 is 1. That is for the top function. For the numerator part, the limit will be equal to 1. And we have So I mean, we have evaluated the limit for sine x divided by x when x is approaching to 0. In the previous video, we have done it with the help of table and graph. So the limit for bottom function is equal to 1. So the limit for this function will be equal to 1.